Hello students, and welcome to a new module where we are going to talk about some of the projects and case studies. The first project that we have is a parking management system. So in this video we are going to talk about that how to create a parking management system in Verilog. So the problem statement that we have is that we have some parking slots. We have to code using Verilog and make a parking management system. Our aim is to tell the person who is coming to the parking lot either the number of parked cars or the number of available spaces. So any information we can display. This parking lot will have a fixed number of parking spots. We can decide the number. At any given time, some of the spots can be occupied and some of them can be available. We are going to design the system which will design the number of occupied spots or the available parking slots. So here is the block diagram. Let us say we have 6 parking spots. Every spot is having a sensor attached. Whenever the car is parked, the sensor will have certain value, and when the car is not parked, the sensor will provide another value. Based on these values, we are going to display that how many cars are parked in my parking slot. So how do we design it using Verilog? We will first of all decide the number of slot and take the equal number of input ports. So if I say I have only 8 spots, that means I can take 8 different inputs, but if I have more or less, then I will take that number. Every slot is having a sensor and we will decide whether the sensor will send logic 1 or 0 whenever the car is parked. If we assume that the sensor is sending logic 1 when the car is parked, accordingly we will design the system. We will count the number of ones and that will give us the number of cars that are parked. So out of 8, if I am receiving ones from 3 different sensors, that means 3 cars are parked. Now we can store this count in a temporary variable and we are going to display this using the 7 segment display. So this is what our code is going to be. Now how do we test it? We are going to randomly place the cars at different locations and we will check if the counting is correct. For simulation purpose, the 7 segment display may not be a good idea because in the waveforms we will not be able to identify whether the displayed number is 3 or 5 or 7 because we are not very much familiar with the 7 segment codes. So here, if you want, you can test using the decimal numbers or hexadecimal numbers also. But when we go for the FPGA implementation, then we will test it using the 7 segment display. So there are some additional features that can be added to this project. These can also be the alternate ways of implementing the project. For example, instead of placing a counter at each parking spot, we can just put the counter on the entry and exit. So whenever some car is entering, the counter will detect the entry and we can say one car has entered. We can put a counter on the exit and whenever some car is detected at the exit, then we can simply say that now the count is decreased by 1. We can also show the number of available spots in the parking instead of just showing how many cars are parked. Now let us talk about the implementation. First of all, let us design the circuit in Verilog. Now we are writing the code. What we have done here, we have taken input which is 7 down to 0, that means 8 possible slots are there. The number of car can be 0 or 8. That means there are 9 possible outputs. If we have to represent 9 possible outcomes, we need at least 4 bits. So this is our output, which is 3 down to 0. If it was 6 down to 0, that means 7 slots, and one case can be everything empty, then we can do with only 2. But right now, if we are taking 7, we will go with 4 bits. We are declaring our output as a register, and the code is very simple. The code just say always @ cars, num, which is my output, that means number of parked cars, is cars of 7, cars of 6 plus cars of 5 plus till cars of 0. So we are just adding all the 8 bits. If it is 1, it will be added and counted. If it is 0, it will not be counted. So that is as simple as it can be. So we save it and now we simulate it. So first of all, what I am going to do, you can see that all these 8 values are Z. So we will say assign constant and you put it 0. So all the values are set to 0 and we run for a small interval of time, and now we can see that our count is also 0. Now you can individually click on these and change. I have put one car here and one car here, and I run it and we can observe that count is 2. Don't worry about the number which is written as 48, which is basically the decimal equivalent of 010010000. Don't worry about that. I place one more car here and then we can see the number of cars are 3 now. If I place one more car here and one more car here, then we place one more car here. So now we can see the count has gone to 6. Now in these 2 spots also we are placing the cars, and as we do that we can see the number is 8. Now if we assign a 0 to the complete number, then all the bits will be 0 and the parking count will be 0. So that means we are able to count the number of cars that are parked in our parking slot. What can be the changes? We can show how many slots are available. That can be very easily done by declaring another variable, and you can call it avail, and we can say that avail is equal to 8 minus num. So we are counting the number of parked cars and we will subtract that count from 8. We will declare avail also as a 4-bit register. So that can also be done. You should try that. So students, now we have checked the functionality of our project. Let us design it for the FPGA implementation and then demonstrate using a new FPGA board. This time I am going to use Nexus 4 board. So keep learning. Thank you.